Okay, so we're going to work on chapter 2, sections 2 and 3. Hopefully we won't be out as early as we were last time, but you never know. So section 2.2 is vectors in 3 dimensions. And we'll announce 2.3 when we get to it. So in 3 dimensions, X, Y, and Z. If you've had any physics in high school or to this point, they always teach you to use your thumb, which is kind of amusing to me. But it's a good visual representation of what they're trying to show you whenever you're expanding that Cartesian plane. Okay. So again, feel free to send me a chat or, let me know if you guys are kind of reviewing this. We'll go a little quicker, but it should be okay. All right, so here's your definition for any of y'all that like to take physical notes. The 3-dimensional rectangular coordinate system consists of 3 perpendicular axes, the X, Y, and Z, and the origin point at the intersection, which of course you would denote as 0, 0, 0, because each axis is a number representing all real numbers in R. The 3-dimensional system is also denoted as R to the 3rd power. So this definition should not scare you at all, right? And again, if I go too fast for the definitions, remember you can always pause them. You can't ask me to go back. Be nice. All right. So here what we're kind of seeing is more of a figure in 3-dimensional space. I did try to go through to make sure that everything we're going to look at has a question and it's not just the answer to a question that we have to figure out. I haven't decided. I'm toying with the idea of possibly having our test in that Achieve system, but you would still take it online with me, like on Zoom. If that's the case, then you might not need to draw as much of this as if you had the course in class. Or, back in the day when I took it, when dinosaurs roamed, and we had to do everything online. Okay. So that was not supposed to come up yet. All right, so sketching the point 1, -2, 3. If you see a coordinates like that, it should not scare you. You should know how to draw it. So I thought of you guys, and I was supposed to hold back, but apparently my mouse does not like me, so it showed you the answer right away. In theory, I would say you probably don't need that box. Like, that's why it's dotted there. If you really, could eyeball that and you didn't want to dot that all out, I mean, I wouldn't take it away from you, but I don't know, my eyes would get wonky. I probably would need that little box. And I think if you're using the Achieve system, most of it has it drawn out for you. So you would just have to sketch it however you feel comfortable sketching it on your notes. Okay. So this is kind of giving us the idea that when we're thinking about 3-dimensional space, right, we're not just out there with only the X, Y, Z coordinates. We also have our planes that are intersecting one another, right? So there we have that. Anybody scared of 3-dimensional space? Hopefully not, because we all walk in it every day, right? Okay. And then this is just kind of showing you that I don't know how you guys were like when you took algebra. I'm sure you guys were really great at it. But when I always, when I teach algebra and when I was taking it, I liked knowing where my pluses and minuses were. So they're just doing that here on a more complicated system. So if this is something that will help you, you can by all means either take a screenshot of it or write it out. I'm sure it's in your textbook. If you haven't checked your textbook out, it's pretty nice for a textbook. I like it a lot. I just don't like how they did their PowerPoints. That's just me. All right. So the distance between 2 points in space, this absolutely should be a partial review for you. Almost all of you should know the first part, right? With the, can I really not write on here? That's hardcore annoying. So obviously if you covered up the Z component, the X's and the Y's you deal with in algebra, bring the Z component in, gets a little bit more complicated, but nothing you guys can't handle. Okay. Any questions on any of this? Okay. I like that my sea of black is slowly starting to become less. I'll get you guys there. You'll get comfortable. Okay. All right. Find the distance between 2 points. Literally going to be using the definition we just went over. So if you guys were taking the notes from that, you can literally pull it from here as well. So we're going to find the distance between 0.1 and 0.2. Here we have our lovely points. We plug it into the formula and we get the square root of 41. I personally like leaving them as the radicals. I don't like decimals. I think decimals are gross. So I would leave it as the square root of 41. The achieve system may take either. It might take either the square root of 41 or it might take the decimal form. You guys will just have to play around with that and let me know. I would hope it would take both. I don't know if any of you guys have had to use Pearson, but I have such a harsh beef with Pearson because there's so many times when I've entered answers and they've been equivalent. And I basically get told by their programmers that I'm doing it wrong, which really drives me up a wall. So, all right. So figure 2.3 is showing us that these two lines are not parallel, but they still do not intersect. Okay. So, obviously we know that's because they're pretty much in two different planes, right? So those planes are not intersecting and they're also not parallel planes. Calm down. All right, these circles are interconnected, but they have no common points. Same concept. Two different planes. I apologize. My dog is being extra right now. Alrighty. So now we're gonna think about writing equations in like the different ways in which we write equations. So you can see that if we were in a one-dimensional space, two-dimensional, and three-dimensional, what that equation changes in how it's presented, even though they are all three x equals 0, right? I mean, pretty cool stuff. Also pretty, stuff you guys shouldn't be scared of. So in this one, Z equals 0 describes the XY plane, and then all points in the XZ plane satisfy the equation of Y equals 0. So again, just trying to show you those two options. Yes, the wrong right answer on Pearson. I will. So this is a side note, and you guys will find out as the course continues. I will side note probably a lot. I've literally had full-fledged fights with Pearson. I've gotten their like reps to get their programmers to get on a Zoom with me, and it truly always does come down to they tend to like to tell me, well, if you want, you can give your students that intro homework assignment again, where it shows them how to enter their answers. And I'm like, this has nothing to do with how my students are entering your answers. This has everything to do with the fact that your programmers are not an end user. So then your programmers think that they know everything. And that's like where their bottom line is. My programmers are good, they know what they're doing, and it drives me nuts. There are so many times where I go into exams and homeworks and I just give students the appropriate points because I know what they did was correct. I've just stopped fighting. I just give points out. That's all I do. All right. Equations of planes parallel to coordinate planes. So you can see here that we would have, your point ABC, and then you would either have Z equals to C, Y equal to B, or X equal to A. All right, you guys should be totally cool on understanding that concept, right? And presumably most of this stuff you should be able to see in the homework. Those of you that did the that finished the homework for the first section, could you kind of see the parallels? I did the homework too. I just didn't took a lot of screenshots so I wouldn't have to draw stuff. I'm a terrible artist, so I can't do any of the drawings. But you should be seeing a correlation between what you're actually getting in class and the homework. So that should be the idea. All right, so a sphere is a set of all points in space equidistant from a fixed point. The center of the sphere, just as the set of all points in the plane are equidistant from the center, represents a circle. In a sphere, as a circle, the distance from the center of a point is called a radius. So I super love that no matter how complex math gets, we still go back to the basics of things. I'm sure there's some cases in physics where it's like, that's just an extra layer. Why do we call it a whole new thing? So I do find that kind of funny. And I'm sure you guys can probably think of some examples. All right, so the sphere is centered at 10, 7, 4, containing the point -1, 3, -2. So now they should want us to write an equation of the sphere. That or they're just giving us this random information and we're not going to do anything with it. But we'll see in a minute. So much like the equation for a circle, this should look kind of similar. It's just adding in the third component of the Z. And oops, there we go. So yeah, we did have to at least find the radius. And then once we find the radius, we can write our equation. Stop that. Ugh. I'm a prolific clicker, apparently. So keep going too fast. Additional side note, I've decided that I'm going to let you guys have a formula sheet. I'm not going to let you guys write on the formula sheet, but this weekend when I'm working through things, I'm going to try and find you guys a Calc 3 formula sheet. I can't promise you if there won't be extra formulas on there. There may be formulas that you do not need. If that is the case, then just ignore them. Or I guess maybe you could make it more legible by getting rid of some of it, but I don't know. I wasn't told that I wasn't allowed to give you a formula sheet. So since I wasn't explicitly told that, I'm giving you one. It's just my feelings. All right. So line segment PQ. P is -5, 2, 3, and Q is 3, 4, -1. Right? I'm assuming, yeah, we had to find something with it. Okay. Since PQ is a diameter of the sphere, we know that the center of the sphere is the midpoint of PQ. So then you find the center, and then once you find the center, you can use the information given and the radius to find the radius. And then once you find the radius, you can figure out your equation. Okay, I do think that was interesting. Okay, so I won't lie to you, my ADHD brain would not have just connected a sphere right away from this. They have two boxes. So my brain would have not just been like, oh, that's a sphere. Line segment can be a sphere. So they're just showing it to you that way. Right? Graphing other equations in 3 dimensions. Describe the set of points that satisfy x minus 4, z minus 2 equals 0. Then graph the set. So I stole the question. They just said the question more as a statement. It's the same thing. Notice what they did do, though. Why do you think that's an important part that they're doing there? What does this kind of give you? Gives you a sense of what you're working with, right? If that wasn't there and you were just told to do this, then potentially if you messed it up, then you would have no idea if what your answer was in any realm of, reasonable. With having an actual sketch, that you give yourself that kind of, hopefully, a little bit more of an understanding there. And apparently we didn't want to do the answer. All right, so feel free. You can do the answer. I'm not going to do it right this second. Oh, because it gives it to us. Obviously, it gives it to us. How nice of them. There we go. That makes sense, right? Plug in the 4, 4 minus 4, 0. Plug in the 2, 2 minus 2, 0. Obviously, I was going way too down the rabbit hole. Have you guys ever done that? I feel like calculus students definitely fall into that trap. When you get to a high enough level, your brain just kind of breaks and you're like, wait, it was that easy? I did that all the time, clearly, because I just currently tried to do it to you. Yeah. So that's me going too deep into the rabbit hole. That question was just clearly so simple that I blew right through it. All right. So now we're looking at a cylinder. Right? The set of points satisfying x minus 2 quantity squared plus y minus 2 or y minus 1 quantity squared equals 4. This is a cylinder with a radius of 2 centered on the line with x equal to 2 and y equal to 1. All right. Describe the set. They already did that. So you can see the stuff that I shoved in, and then obviously at almost midnight, my brain was just off. I just wanted to help you guys out by not having to just look at just answers. I love all their drawings, but notice that they use a nice computer program. I'm not going to sit there and do that. I also won't show you guys any of the stuff that I draw because it does not look nearly as nice. All right, so vector V 241 is represented by a directed line segment from the origin to point 241. You guys cannot get that. All right. And that's all they wanted you to know. They wanted you to be able to draw it. All right. The vector with the initial point P, 3, 12, 6, and the terminal point Q, -4, -3, 2. You would have your drawing, and then in component form, and then standard form. So just so you're aware, I am going to be making the PowerPoints so that we will be filling in this information together with my tablet. So I'll be physically writing. I just apologize. It's not going to happen for today. Questions on how they got their answers for standard form or component form? If you did the homework already for section 1, you should feel comfortable at least seeing where they're coming from for this stuff. Okay. I believe Achieve takes either option, and I think they tell you. Like, I think they say to you, your answer can be in component form or in standard unit form. I'm weird. I like standard unit form. I don't know why, but obviously component form is fine too. Okay. We're at like 25 slides, so any questions? No? Okay. You'll get questions. You'll end up having them, I promise. It just might not be with chapter 2. All right. To add vectors in 3-dimensional space, we follow the same procedures we learned for 2-dimensional space. If no one saw that coming, I would feel a little sad. Okay. We're just taking our triangle from 2 dimensions and we're making it into a pizza box. And that will help you find your answer in 3-dimensional space. Okay. All right, properties for vectors in space. This should look fairly like building upon the past. I give them to you mainly because I haven't given you a formula sheet yet. So I guess in a way you're building your own. But I'll try to get you guys an actual formula sheet. Unless maybe I just give you the properties. I don't know. I haven't decided yet. You're definitely getting something. I just don't know if I'm making it or if I'm going to find it. All right. So you can see your scalar multiplication there, your vector addition, your vector subtraction, your vector magnitude. All that should be pretty not scary and just be able to use it. Okay. All right. So vector operations in 3 dimensions. Here they give you a vector v and a vector w, and then they want you to find the following vectors. I do think it's neat that they don't say find the following solutions or find the following answers. They want you to know that when you're working with vectors, your results will be vectors. So it's kind of neat that they continue that. If you wanted to draw this out to have that as a reference, you could. I think I keep it. Nope, too big of a solution. So if you want to draw that out and write it down, you can, and then we'll go over the solution. Okay. So I do want you to take a look at these. You will have questions like this on your homework. I'm sure you'll have at least one of them on your test. Mainly because I make up your test, and this is a nice question. It's nice and simple. All right, so 3b minus 2w, you're just going to distribute and then bring your components together. You can see for B, they needed to find their vector, and then they're multiplying their vector by 5. No, stop that. That time it wasn't even a click, it was the wheel. So annoying. And then we use scalar multiplication and then the magnitude to find yet another vector. And then recall that to find a unit vector in 2 dimensions, we divide a vector by its magnitude. So we do the same thing in 3 dimensions. Okay, so taking everything you've done in 2 dimensions and now adding a third. Pretty sure we don't add a fourth in Calc 3, so fingers crossed for that one. Anyone need any extra time on writing all that down? I know it's a lot, but again, I do record everything, so. And you can always fast forward through my rabbit hole moments. I also will definitely let you know to appreciate the earlier chapters because we probably will end earlier than 7:30 the first few times. And then we'll probably definitely need the 7:30 or potentially a couple minutes over. So this image here is just depicting what we're going to do next, but I guess I wanted to have it by itself for a minute. I don't know. I left it there by itself. So you can see what they did is they had their, obviously, like the orientation of what's going on physically. You know, the quarterback is throwing the ball. And, you know, we're supposed to assume that both the quarterback and the receiver are not having the ball at the same point in time. You know, we're not going to go down that time dimensional rabbit hole, even though that's very clearly what they're showing. They each have a football. This would not really happen, right? So I just find that vastly amusing. And then in this one, what they're doing is they want you to find vector W. So now they've just drawn it in that orientation that's a little different. So the first thing we want to do is to find a vector in the same direction as the velocity vector of the ball. So they're going to consider that vector W. So the receiver is 20 yards down the field and 15 yards to the quarterback's left. Therefore, the straight line distance from the quarterback to the receiver is going to be 25 yards. Okay. All right. And I'll let you guys read through this. You will have to do application-based problems. I do like application problems. I do not give you anything that you haven't already seen. So you may end up seeing something like this on your test, just with different information. I'm not sure, haven't made it yet. But I am not someone who likes to throw application problems at you and be like, haha, we did application problems in class, but not one like this. That's just not what I do. We'll more than likely go over every type of problem that you would have on your test. Okay. So at the very end of all of these steps, then you find that the magnitude is 60 miles per hour. So then, yeah, problem's done. All right. Any questions on section 2.2? That application problem was actually the end of it. I had a feeling it was. Okay, so like to sum up section 2.2, we're taking what we know about vectors in 2-dimensional space and just adding in now the third dimension of plane Z or XYZ. Okay. All right. So the dot product, you guys should recall dot product from 2 dimensions. Now we're just doing it with 3. Very similar process, U dot V. And I believe section 2.4 is the cross product. So we're going to get to that next week. So U1 times V1 plus U2 times V2 plus U3 times V3. So there you go. That's easy. You'll have to do it, some of it for your homework, of course. I will let you guys know. I don't know why why in math in general. So obviously, and again, sorry, this is my ADHD brain, but so we obviously had math invented like what, 400 or 500 years ago, something like that. We have 27 letters in the English language, and yet for some reason they love to pick letters that are so closely similar so that we sit here and go, that all looks like the same thing being multiplied together. If you want to use A's and B's, C's and D's, you really want to screw yourself up and do P's and Q's, I don't really care what you use, but you don't need, as long as you get the concept, you don't need to worry about using U's and V's or whatever. Use whatever you want to make yourselves understand it. Remind me at some point when I'm not recording to tell you guys a story about my calc professor in college. All right, so calculating dot products. Find the dot product of U, given that U is 3, 5, 2, and V, given that V is -1, 3, and 0. And then find the scalar product of P and Q. Okay, so again, if we had had a little bit more prep time, we would be handwriting all of this out together, but we'll just kind of talk through it. So we're going to substitute into our dot product formula our given information. So 3 times -1 will give us -3, 5 times 3, 15, and then 2 times 0, of course, is 0. So we get a dot product of 12. And then we're going to do the same thing with the scalar product. All right. That should be, everybody should be happy with that kind of question, right? Definitely should be able to handle that on the homework. Right. And I know there's only 11 of you, so please just try to get your homework done on time. It will benefit all of us if we don't have to get behind. Okay, so again, our properties, I mean, they do look very scary. Obviously, if you were just seeing stuff for the first time, could you imagine if that's how we taught those properties? Like, you know, in 3rd and 4th grade, someone just threw those there, and that's how they taught the properties. I'm sure little kids would be like, oh yeah, the teacher put this stuff up there. We do this stuff. I have no idea what it means. So I don't know, just find it funny. Okay, so using properties of the dot product. Again, they give us A, B, and C. We want to find the following products. So we do A dot B, and then we're going to multiply by C. Okay. And then they want us to do A. Well, first you're doing 2C, and then they want us to do A dot the answer to 2C. Okay. And then the magnitude squared. So take a quick look at that. Make sure you follow all of their steps. And then definitely let me know if you don't understand one of the steps. All right, thank you. And then if any of you are interested, I'm not sure when I'm going to be working on things this weekend, but if I work on some of the homework, if you guys are interested, I can always put up an announcement. So if anyone wants to work on anything with me, either in a small group or one-on-one, we can always use the Zoom and we can work on stuff together. That doesn't bother me. So theorem 2.4, evaluating a dot product. The dot product of two vectors is the product of the magnitude of each vector and the cosine of the angle between them. Okay, so I feel like this was probably presented in trig a little bit. This should definitely be a formula you've seen in the past. So here's our little inclusive angle. It's telling us that it's that theta is between 0 and pi. So all that good information that we need to make sure that the problem will not work and not blow up in our face. Okay. The lengths of the sides of the triangle are given by the magnitudes of the vectors that form the triangle. Okay. All right. So finding the angle between two vectors, find the measure of the angle between each of the pairs. So they give you two vectors. They're giving them to you in two different forms. You can write them however you like. If you like the way B is shown versus the way A is shown, just rewrite it, or vice versa. You're still going to do the same things with them. You're still going to you're still going to have the same processes. They just like to show you that those are the same things. I won't lie to you. I don't think I would have written the first step like this. Would anyone have written the first step like that? I mean, it's not wrong. I just feel like, me personally, I probably would have messed something up if I included those letters. So I would have just gone straight to the second step. That's probably how I would have looked at it and how I would have done it. I don't even think I would have written that teaching it. I probably would have gone just straight. I guess if you needed to, you could kind of see that as the formula in a sense. I don't know. I wouldn't have done it. But then that being said, I would have done the first step of the second one. So I guess I just like the way B is presented over the way A is presented. Right? Should be good to go on that. So orthogonal vectors are the non-zero vectors u and v with orthogonal vectors if and only u dot v is 0. So you can see here there are some examples. They give, this is probably a very nice slide, even if you're not a note taker and you're just a listener. At some point, you probably want to at least write or sketch this down, this part. So, or not. And I mean, you don't have to do it right this second. You can always do it later. It's in your sketchbook. It's in your textbook. So it is available to you. Right. Identifying orthogonal vectors. So here we have vector P, which is right here, 1, 0, 5. And then we have Q, which is 10, 3, negative 2. So vectors P and Q form a right angle when their initial points are aligned. Okay. And then here's our solution. Using the definition, we only need to check the dot product of the vectors. Okay, so because P dot Q is equal to 0, the vectors are then orthogonal. Okay, that's literally all it's telling you to do. You don't have to go crazy and try and find the distance between the two. You're just finding the dot product. Okay, makes sense because that is what the section is. I think I literally just realized how math can be like connected to video games. You know how like in a video game where they show you the method and then they make you for that certain amount in the chapter, you have to use that new technique. That's what math is doing. In the section, we have to use this technique. Wow. Can't believe it took me that long. Probably would have had a lot more fun with it had I remembered that. All right, so here we're measuring the angle formed by two vectors. So if we let v equal 2, 3, 3, find the measures of the angles formed by the following vectors. So v and I, v and j, and v and k. Obviously I, j, and k being your 1, 0, 0, your 0, 1, 0, and your 0, 0, 1. Okay. They probably should have told you that. I guess they're going to assume that you would know that. Which is fine. I guess it's a fine assumption to make, but in case you couldn't make it, it's been made for you. So you're just plugging it in. Again, if you guys don't like the first part and you can see straight to the second part, go ahead and go for that. Dot product should not be too scary for anybody. As long as you guys are doing the homework and putting in your practice, you should be more than fine for at least chapter 2. All right. So the next definition says the angles formed by a non-zero vector in the coordinates axes are called the directional angles for the vector. The cosines for the angles are called the directional cosines. Angle alpha is formed by vector v and unit vector I. Angle beta is formed by vector v and unit vector j. And angle gamma is formed by vector v and unit vector k. Okay, and there's our cute little drawing that if you stare at it long enough, the box will flip sides. So I don't recommend, but there it is. All right. Getting pretty close to the end. So I just wanted to include this twice. I don't know why. You're gonna see it again in a second when we actually have the problem. I guess I just wanted you to have a big version of it. When a child pulls a wagon, only the horizontal component of the force propels the wagon forward. Okay, so yeah, I guess I just wanted you guys to know that. I think it does come back, maybe. So here's a very large definition. Vector projection. So it's the magnitude of v times the cosine of theta. You know that you can replace the cosine of theta with your dot product D formula here. So we now multiply by a unit vector in the direction of u to get the projection of v based on u. Okay. And then the length of this vector is also known as a scalar projection. Okay, so you have two nice formulas that you'll be working with, I'm sure, on your homework and later on our review and then our exam. Okay. So finding projections, find the projection of v onto u. So the projection of v onto u shows the component of the vector v in the direction of u. So again, we have a drawing, a sketch. Please get in the habit of doing sketches. If you can do the math and you're, without the sketches, more power to you, but I really think the sketches help people out. Okay. All right, substitute the components of v and u into the formula for the projection. So we were just given all of this. If you didn't write it down, or at least if you didn't pay attention to it, there it is. So 351 and negative 143, and then 3i minus 2j, and u is I plus 6j. Sorry, my phone's going off like crazy. So we're going to substitute the components of v and u into the formula for the projection. So here we go, plugging it all in. And then again, okay? So, all right, pretty close being done. A scalar projection of velocity. Here's our nice little boat. A container ship leaves port traveling 15 degrees north of east. Its engine generates a speed of 20 knots along the path. See the following figure. In addition, the ocean current moves the ship northeast at a speed of 2 knots. Consider both the engine and the current. How fast is the ship moving in the direction 15 degrees north of east? Round your answer to 2 decimal places. So you work your projection out, and you end up finding that the ship is moving 21.73 knots in the direction 15 degrees north of east. Obviously, I did not sit here and do all of this stuff with you. These PowerPoints are very horrible. It will get better. Any questions on the majority of everything we just covered? This is a work definition. If you've taken any kind of physics, then it should look a little bit familiar to you. Might be a little different because of how we're working it. You would just plug in our same red wagon, right? 55 degrees, 50 feet to the front, 8 pounds force. You would plug it in. So 8 times 50 times your cosine of 55 degrees gives you 229 feet per pound or by pound. And I think that's the end of it. Oh, no. Is there more? Wow, guys, I really went crazy. I will also let you know, though, that section 2.3, I think it is, I did not pull all the examples. I got to a point where I just thought it was a lot. So if you read over section 2.3, you might come across some additional examples. Feel free to write them down. I just didn't pull all of them. All right, so calculating work. A conveyor belt generates a force of 5I minus 3J plus K that moves a suitcase from the point 111 to the point 947 along a straight line. Find the work done by the conveyor belt. The distance is measured in meters and the force is measured in newtons. Okay. So the displacement vector PQ has an initial point of 111 and the terminal point of 947. So to find PQ, you end up getting 836. And if you prefer the other option, 8I plus 3J plus 6K. And then we just plug it into our work equation. So you have your force dot your dot product with your PQ, and you end up with an answer of 37 joules. Okay. I'm sure you've heard this in a lot of classes. Calc 3 is no different. If you have a unit, you need to make sure you're using your unit. Okay. So I don't personally care what the Achieve system does. If it doesn't want your unit written down, that's fine. Don't write it down. Don't get the problem wrong. But on your paper, you need to make sure that you understand that you have your units. They might give you the units on the Achieve thing. It might tell you what the unit is. But on your test, you need to make sure if you want full credit from me, you need to have your units down. All right. So last thing we're going to talk about here is our homework. So all your homework for sections 1, 2, and 3 are due by September 3rd. To prep for next week, you need to read sections 2.4 and 2.5. Obviously, I recommend taking your own notes. We will be going through, and the PowerPoints will be better next week. I am going to stop the recording.